Right, now we'll get into the meeting. Right, so welcome everybody to the July 2025 meeting of the Mornington Peninsula Astronomical Society, and shown here are some of the things that have happened in the last month or so. First one at the top left with the NASA symbol there. It's been announced that the incoming NASA, new NASA administrator that was being appointed by the President of the US has now been dumped after he sort of hinted that he didn't like the idea of them cutting 2,000 scientists from NASA and a 50% cut to all their science programs. And so consequently he was dumped a couple of days before he was due to go into the job. And now instead they've put their transport secretary, who's part-timer looking after NASA, as well as doing transport secretary. And he has to, what was the term, mission reprioritisation, to make everything America first, right? All the programs in it. So yes, Fred.
This dumping of 2,000 jobs, some of you know, you can't go into that without assuming. What actually was going on there, you know?
Don't ask me. Don't ask me. Yeah, I suspect that NASA is going to probably fade away until they have a change of direction. And I would think that the major space agencies that we're going to see now is the European Space Agency and maybe the Japanese as well, as being the major players, at least until America sort of comes to its senses, I suspect. Now the other thing, if we move across to the right, in the last month or so there was another interstellar object came in. If you remember the one Umawa some time ago, long cigar shaped thing that came racing through the solar system. Well, this is another one thought to be somewhere around about the 1 kilometre size, maybe plus or minus, they're not entirely sure. And that's been given the designation 3I/Atlas after the Atlas telescope in Chile picked it up on July the 1st. ATLAS stands for Asteroid Terrestrial Impact Last Alert System, which is a rather ominous sounding name for a telescope if it's the last alert system before you hit it. And they believe it won't come back, and it's come from another solar system because it's been travelling too quickly, about 60 kilometres a second, which is getting on for twice as quick as anything that you normally get in the solar system. So it's zipping by the sun and on its merry way without being captured by the sun. Down in the bottom left-hand corner, the circular image there is the James Webb Space Telescope turned its coronagraph onto a star 111 light years away, and the coronagraph has put the little black circle on the front of the star there to block the starlight, so that you only see the light that's coming from the dusk disk around the star, so a protoplanetary disk. And they've detected by direct imaging a planet there the size of Saturn. And that's actually shown by the circles up around the 2 o'clock mark on that circle there. And they've convinced themselves that that indeed is a Saturn-sized planet that they've directly imaged. So all the other ones have tended to be via transit. They've detected them because when the planet moves in front of the sun, that particular star, it blocks some of the starlight and causes a slight dimming of the star that they're observing. But this one is a direct imaging of the planet. And the unusual thing in this case is that we're seeing the solar system from above, so you're seeing it face on. So you see the star in the middle, and the actual protoplanetary disk is almost at right angles to us, so optimal conditions for seeing a planet. Over on the top right hand side there we see the new Vera Rubin Observatory in Chile that has come online. This has got an 8.4 metre mirror, so quite a decent sized mirror. And it's also the largest digital camera as well. It's 3.2 gigapixels, so quite large. And it's 3 tonnes as well, so it's quite a hefty camera, so not for your average amateur. And that began operations on June the 24th. It looks at the entire southern sky every 2 days and will do so for a decade. So it takes images of everything in the southern sky and then 2 days later it does it all over again. And it compares frames on the fly as it's going. And with that, it's in its first week of operation, it found over 2,000 new asteroids, and you can see the little clip here that is running. You'll see as it picks up more and more asteroids. These are all previously unknown asteroids that it picked up with no problems at all. It's primarily a survey instrument, and so it should be able to find lots and lots of these over time. And as you see, there's several hundred or more of these that have been picked up in just its first 7 days by comparing frames. And we should actually see lots more of that in the future. So tonight, welcome any new members here, and since the last time we read this out, our new members are Alex Simon family, Brad Green, Mark Rookledge, Erica Burmeister and family, Andrew Wilson and Craig Hill. So any of those members here tonight? No, none here tonight. Sounds like it's raining outside as well. Yeah. Okay, well, we'll move on. Look at the events past and coming. There won't be an Astromofo tonight because Chris is not here. Then I'll throw over to Guido for Sky for the Month, and we were going to have a talk on the Australian Space Summit. I think that been handed over to you, Guido? No? Oh, okay. So David Rolfe was going to do that, but he pulled out at the last moment, feeling unwell tonight. So maybe we'll show that at next month's meeting. Then Trevor will try and talk over the rain on humorous reflections on presenting. And then we'll look at about a 15-minute video on does the past still exist from a German quantum physicist, Sabine Hossenfelder. We've shown something of hers before. And then at the end we'll close with looking at the evolution of the moon from after its formation to today, what the main events that have happened. So recent events in the last month, we see some there. On the 20th of June we had the winter lantern making here at the Briars, which Phil kindly liaised with the Echo Centre and proved to be a big success. They had about 30 lantern making next door. Was that in the geodesic dome? The big dome next door, Phil? Yes, it was in the geodesic dome. And then they came round here for some stargazing, and they were quite lucky that it was 0% cloud at the time, so they got a good evening. The next day there was the Working Bee member barbecue here at the Briars. On the 24th of June we all went out to Narrawarren South under 100% cloud, so they didn't get to see anything in the sky. But we got to see their new scout hall and gave them a talk. The next day we had a committee meeting by Zoom, which was talking about the Indigenous talks, one of which is this coming Saturday here. The astrophotography workshop, planning of that has now begun, and we talked about the dome going up for David Girling, the member who passed away several years ago, and other project ideas were put forward. Next day there was the second Mornington Joey Scouts here, and that was with Anders Hamilton. Then on the 1st of July, several members, three shown there, went to see the Canadian astronaut Colonel Chris Hadfield up at Melbourne Hamer Hall. And from that we actually learnt what the connection was between a black hole, the Earth, and a maraschino cherry. Hence that's why there's a picture there, and there is a connection. And on the 4th of July we had the public night here, and that was the 150th as well of Trevor. So 150th public talk that he's given, and that was where we handed out 150 Mars bars, and I think there was some remnants of those left outside if there's still any there now. And what the connection is between a black hole, Earth, and a maraschino cherry is how you turn Earth into a black hole is you need to squeeze it to the size of a maraschino cherry. So if you squeeze the Earth from all sides down to that size, it will turn us into a black hole. So there we go, now you know. Coming up soon. Well, it's going to be a busy month ahead of us. And I've generated this image in the background from AI, and the faces at the front look like happy smiling kids, but they get more and more grotesque and alien as you move backwards, and I'll have to ask Guido sometime as to why that happens. Some of the kids have their mouth off to one side, others don't have a mouth at all and don't have a head, and they look pretty grotesque. But there's hundreds of kids running at us, right? So the 19th of July, this Saturday, it starts with the Cosmology Discussion Group here at the Briars at 1:45, then followed by the Working Bee and Member Barbecue at 4 p.m. Then after the barbecue, we'll have Indigenous Astronomy STEM talk, so science, technology, engineering and maths, by visiting speaker Dr. Tim Patson from the University of South Australia. That's come at fairly short notice, so hopefully we get enough members able to come on Saturday night. We can't give you an exact time on that because it all depends on when the barbecue is finished. So he'll start when the barbecue ends. 23rd of July will be the next Zoom meeting of committee. 25th of July we have the Skag Night, the Scouts, Cubs and Guides here at the Briars. Note the earlier start time of 7 p.m. Normally it's 8 p.m, but this one will be 7 p.m. because the majority of the ones there are pretty young. And at the moment we've got 13 booked, and we're suspecting that there will be quite a few more coming to that one as well. 1st of August, the next public night, I believe Guido's talking at that one. And that one's fully booked out and has been for a few months. 6th of August, we've got Glenferrie Primary School next door at the camp, and we're expecting quite a few for that. 9th of August over in Geelong, we've got the 20th Vastrock, so the Victorian Astronomy Conference there, and you can book tickets now. It goes from 9 o'clock in the morning till 10 o'clock at night. So it's the ASV's chance to actually host it this year, and their Geelong section has kindly offered to be the host this time round. So it's a one-day thing only on the Saturday, but you can book it now. And if you go to that website that's shown on this slide, vastrock.net, the link to booking is actually there, and the details of where over in Geelong. 11th of August, we've got 100 expected out at Cornish College in Bangholm. So that's the one near the Paterson River, in sort of way past Bangholm Way. Yeah, that's right. Yeah. That one is most of the year levels from year 4 up to year 12. So it's pretty much the whole school. So we need quite a few people coming to that one. 13th of August, we have one confirmed at Chelsea Heights, up at a reserve up there for the public, and we're expecting about 100 people to come along to that one. 14th of August, the very next day, we've got a big one out at Balnarring at the primary school, so it won't be here at the Briars, it'll be actually at the school, and that's whole of school, so 150 kids from prep up to year 6, so this is primary age level. So we're going to need a lot of people out at Balnarring for that one, for 150. 15th of August, the public night for National Science Week, he'll be here, and Trevor will be giving that one. That one's also sold out at 90. Then the day after, on the Saturday, 16th of August, we've got a group of families from Hong Kong visiting, and that will be here at the Briars. And we'll give them a talk, and we've already got 97 booked for that one, so we've got plenty of chairs to fit them in. And then the next meeting like this is over on the 20th of August.
Okay, so we have Sky for the month for the rest of July, and then the first half of August, starting with a look at the solar system. Just get the laser pointer here. So as you can see here, this is a scene from the top. We have the Earth around here. Anything that's kind of towards the sun in this direction is the early morning sky. Anything towards the sun in this direction is the evening sky. So we can see that Mars is now still in the evening sky, but getting a bit further away from us. Mercury is almost between the sun and us on the 1st of, I think this is pretty much around now actually, and then Venus is in the morning sky here. And if we zoom out a little bit to the outer solar system, we can see Saturn and Neptune here moving. Sorry, that was a bit too quick. Maybe I can zoom back there, so we can see Saturn and Neptune. Where are we? You can see Saturn and Neptune here in the. So they were in the early morning sky, but moving closer and closer to regular observing times. So as we'll see later in August, Saturn would actually rise around 9 p.m. or so. And the other thing is that Jupiter is currently hiding behind the sun there. So if we look at the inner solar system over the next month, we can see Mercury here starting to move between the sun and us, so it won't be visible for a little while, and we're catching up to Venus here and moving a bit further away from Mars over the next month as well. So let's have a look at that from the all-sky perspective. So this is on the 1st of August, and we will have the sun setting around, I think, 5:30 or so on that day. And the only planet we can't really see here is Mercury, because that will be at its inferior conjunction, so what we saw right now, where it's between the sun and us on the 1st of August. And then in the early evening sky on the 1st of August, we have Mars here setting around 9 p.m. now, so still visible at the moment, but setting earlier and earlier. And then for the moon for the next month, we have the new moon on the 25th of this month, and then the full moon on the 9th of August, and the next new moon on the 23rd of July. So let's have a look at a little bit later in the evening around 10 p.m. Still looks pretty similar to last month, where we have really the Milky Way stretching across the sky, the core of the Milky Way nice and high. And I guess the main stars at the moment would be, well, still we have the pointers here, right? Then Antares, Arcturus very low on the horizon, and Altair and Fomalhaut now also, and Achernar here as kind of prominent stars around 10 p.m. I think the next thing is the constellations for around 10 p.m. And it's currently mostly really the constellations around the Milky Way here. I think I had to update my computer, and apparently it switched all the constellation names to their kind of normal English names like Southern Cross and Southern Crown and so on. So that's a little bit confusing. But one thing we can see is that we will actually see Orion rise again early on, so it will become visible again over the next months. So Saturn now rising at around 9:30 p.m. So about, I don't know, I guess 1 or 2 months from now, hopefully that will return to proper viewing times for our public nights. Neptune is very, very close to Saturn at the moment, so within a degree. Then Uranus now is an early morning object rising around, I think, 3 a.m. or so. And then Venus and Jupiter are quite close together, both morning objects, and Venus will be in conjunction with Jupiter, I think also within maybe 1 or 2 degrees on the 12th and 13th of August. Jupiter has now passed its conjunction with the Sun, so it's a low and early morning object, but it will start rising earlier and earlier over the next few months as well. And sunrise around 7:20, so that's getting a bit earlier again compared to last month. Quick look at the apparent sizes of the planets. Mercury looks very big here, but that's because on the 1st of August it will be at inferior conjunction. So don't look at Mercury because it's right in front of the sun, or in exactly that direction at least. Not right in front, I guess. There's no transit this time around. But that's obviously when it's at its closest to us, and so it would appear at its biggest as well, but of course we can't observe it. Okay, just as any previous month, no comets brighter than magnitude 10, but I thought I could also have a quick look at this new comet that Peter already mentioned. So it has actually two different names. The first one is 3I Atlas, where 3I I think just stands for the third interstellar object that was discovered. But then they did some more measurements and found out that it is most likely a comet, so they also gave it a comet designation, and that's just C2025N1 Atlas. So both of those are the same object. As Peter said, it was discovered on the 1st of July. It's traveling at 61 kilometers per second relative to the sun, and that also means that it's by far the fastest interstellar object of the three. So the two earlier ones were also interstellar, so also going at a speed that means that they will leave the solar system, but this one, I think it's about 3 times as fast as the others. And I found this animation really nice because it shows the orbits of the inner planets and Jupiter. And they're all nice, kind of, I mean, almost circular orbits, like the planet orbits are. And then you can see this comet here on this highly, well, it's not even a highly elliptical orbit anymore, right? It's a hyperbolic orbit, which means that kind of it opens up so far that it never comes back to the sun, right? Because it's going so fast that the sun cannot capture it with its gravity. What's interesting here, I don't think you can read the dates here. So this is from around now, August. And so you can see the closest approach to the sun will be in October, but the Earth will be on the other side of the sun at that point. So we won't actually be able to observe it at that point. But a little bit later in the year, when we've kind of come around a bit more to this side, so around November or December, it may actually become observable. So it'll probably be only around magnitude 11 at that time, but at least with telescopes. So it's not an object for binoculars or even naked eye observation, but it may actually be observable with telescopes towards the end of the year. So that might be fun to maybe even take images of an interstellar visitor. And so while it's going a lot faster than the previous ones, it was discovered a lot earlier. So the previous ones were basically discovered on their way out of the solar system. But this one was discovered basically on its way towards the sun. So we have a lot more time to observe it now over the next half year or so. And finally, this is really just the same slide as last month. Meteor showers. We have 2 that are, I think, both not very good for us. But so the southern delta Aquarids are peaking around the end of this month, and the Alpha Capricornids are also peaking around the 30th of July. There shouldn't be any interference from the moon because this is, I think, just after the new moon. So that's the only meteor showers that are currently observable. And sources, as always, were from Stellarium, NASA Eyes on the Solar System, the Astronomy Yearbook, and this nice animation was from of the interstellar visitor was from Wikipedia. And that's all. Thanks. Any questions? Fred?
Good. I noticed that the planets, have they got rid of Pluto out of one of the major planets now, or will it be reduced?
Pluto hasn't been a planet for over a decade now, I think. Yeah. I could put it back in just out of interest, but yeah. Yeah. Okay.
And for those of you who don't recognise Trevor, that's what he looks like. He's going to talk on humorous reflections on presenting, He's a current committee member and has been presenter at MPAS for over 12 years, so reaching 150 just recently. He's a so-called enrichment speaker on various cruise ships, so he's... how many cruises have you done now?
I think about 17.
17 cruises, there we are. He used to work when he's in his earlier days as Principal Telecoms Tech Officer at the Telecom Research Laboratories for 25 years. That's the one near the synchrotron, isn't it?
Yep.
Yep.
It was next door to the synchrotron, and then bulldozed the whole research labs and put it in a hole in the ground.
Working with solar panels, optical fibres and cable internet, and after that he worked on electronic pricing and sports scoreboards, software development, and he's, I made a mention there, he's a proud new owner of an electric car which he drove down to the Briars tonight.
It's done nearly 800 kilometres now.
Yeah.
So I'll be talking about a few different subjects. I've also got, if you come to any of my talks previously, I usually have a lot of props with me. I have some props here, but normally I bring astronomical ones. Most of my props are actually from dinosaurs. So you'll see something that I don't normally show at the talks at the Briars. So I'll be talking about dinosaur talks. That's how I first started doing presenting to school kids and stuff. And I've got a few funny things, like little kids can be very funny, right? Border security, some of the problems and things I've had with border security when you have great big lumps of iron in your suitcase, queries about customs, and the subject of astronomy seems to attract people who want to know all about aliens. And I've encountered a few people who maybe they're a little bit sort of an alien in their own mind as it is. So, and that's a few interesting little quips as well. So I'll turn this on and it'll work even better. Right, so back in 2009, I started my first presentations. I actually, if you've seen my car around, my number plate is D1N OSR, Dinosaur. And I used to have my X-Trail wrapped, so it had pictures of dinosaurs and everything around the car. And then when the GFC came around, all of the bookings just sort of evaporated. All the money that the government gave to schools for incursions, we don't go in with a machine gun and shoot all of them, unless you pay me enough money. But excursions, incursions where they have someone come into the school and talk. So I did a number of incursions into primary schools and schools, some high schools, etc., talking specifically about dinosaurs. And one of the things that I used was using teeth to explain what we thought dinosaurs would have eaten. And I brought some dinosaur teeth along with me, as I have tonight. So, for example, if we were to look at the teeth from a Triceratops, and this is a Triceratops tooth, right? If you look at it later, you'll see that the top of the tooth is a little bit similar to our molars at the back. Very similar, it's got two sort of caps on it and it's very flat. So we would say that they probably have teeth like this for eating plants. Or the mosasaur, which was sort of like a shark or something like that, I guess you would say. This is a section of a mosasaur jaw, so you can see how big the teeth were, and then there's another tooth on the side there as well. Because they had big, long, sharp teeth, they probably ate fish and things like that. As I say, very similar to a shark, but compared to a white pointer, they could have a white pointer for breakfast, right? Much, much bigger, probably as wide as this room. And you imagine something coming at you like that. So, because it's got sharp, pointy teeth, oh, that's good. They probably ate fish, something like that. They lived in the water, they had flippers. The Spinosaurus actually lived in an area around northern Africa, and it's dark here, I can't see. Oh, there's my little box. Right. And it lived on the coast around an area of North Africa. It has a head very similar to a crocodile, very, very sharp teeth, and so they believe that would have eaten fish or something like that. right? Fish or something like that. It also had this very big sail on the back. They believe this was for thermal regulation, so if it was a cold day, it could turn sideways to warm itself up, and if it was a hot day, it could turn edge on, so a breeze could blow past the sail in order to cool itself down, to regulate temperature. And because it had these sharp teeth, you can see this is a Spinosaurus tooth. It's actually about half a tooth, so it's been broken off at the jaw, and the remainder of the tooth would still be in the jaw somewhere. So quite a large tooth. As you can see here, the actual tooth, this is not real size, I should point out. So this tooth would be maybe about that sort of size. So quite a large tooth, but that's not a tooth, right? This is a tooth. This is a reproduction of a T-Rex tooth. So if you look at it there, you can see there's a little bit of a ribbing on the side. That's where the tooth came into the jaw. So this much would have been above, and most of the tooth down into the jaw. So very, very strong connection to the jaw of a T-Rex. This is a copy made in China. It's a genuine copy though. It's not a copy. If you wanted to buy a real T-Rex tooth like this, probably 50, 60,000 US dollars perhaps. You can get a broken one like that for maybe 4,000 or 5,000 US dollars if you hunt around. So T-Rex teeth are very expensive and sought after, right? So you can see the teeth into the jaw. The interesting thing about the dinosaurs is all their teeth were the same. So if they had sharp pointy teeth like this, all of their teeth were like that. In something like the Triceratops, all of the teeth were the same. Unlike ours, where we have our molars at the back and incisors and sort of canines on the side, but thankfully we don't have teeth like a dog, because it's bad enough when you bite your lip as it is without having a canine that would skewer the side of your lip. So then I would ask, particularly primary school kids, this was the funniest part, right? We can speculate on what dinosaurs ate by the shape of their teeth, but is there something that we can find and we would know exactly what they ate, right? And I could see usually there would be a row of teachers at the back and all the kids at the front, and the teacher would say, "You can say it, you can say it." And then usually it would be a boy, but not always. They'd put up their hand and go, "Poo?" And you go, "Yes." Who'd think that you're in school and your teacher would say you have to say poo? That's the right answer. So dinosaur poo, if you could find dinosaur poo. Or the scientific name, coprolite, which comes from kopros, I think, which means basically poo in Greek. So I would bring out my sample of genuine dinosaur poo. So this is real fossilised poo. Of course, the first thing that kids of that age say is, "Ew." The second thing they say is, "Can we touch it?" Because they want to come up here and touch the poo, and they'd wonder, can we actually touch this poo? I think any bacteria that's on this would be about 100 million years old. The poo is, I wouldn't eat it, but I don't think it's got any of the original bacteria on it. Which reminds me of a little bit of a story that I'd heard. So this girl asked her mum, "Mum, where does poo come from?" And so of course the mum wants to this is a learning exercise. So we go through the proper explanation. So, you know, when you eat your food and you chew it all up and it goes into your stomach and it goes through your intestines and your body takes out all the good stuff. Right, and the stuff that comes out the end, that's your poo. And the girl looks at her mum and is really puzzled and sort of thinks, but where does Tigger come from? Right, So after about 9 years of talking to school kids and also talking down here at the Briars, at PVNs and some of the other special events, etc., after about 9 years and more than 150 talks, I was able to get a position as an enrichment speaker on a cruise ship. As you can see, the audience is a little bit bigger than what we could fit in here, usually around the 300 to 600 people. At that time, I'd presented to about 8,000 people in total. I have a logbook of every talk that I've given, so that when I come to the Briars to give a talk, I don't give one that I gave 2 months ago or at the same time the previous year, so I can rotate them through. So if people always come in June, if I'm talking, it won't be the same subject as what it was the last time they came. So every C day, I would give a presentation in the theatre about something. I get to use all of the presentations that I've already created for talking here at the Briars. I did measure the time it took me to make a talk once from scratch, where I had no pictures to work from, I had no previous presentations, it was from scratch. It took 100 hours to create one 45-minute talk. So a lot of work. It's a lot quicker now because I can take pieces out of existing presentations to build up other subjects as well. And of course, aliens. This is one of the... There's always people who have come down to me and asked me, when you've looked through a telescope, have you seen anything? Right? Like, have you seen Voyager or something like that sailing past, or a spaceship or something? And of course, all of us here would know, no, we've never seen anything in a telescope. Or do you believe in aliens or anything like that? So I've had a number of people that would follow me, sometimes almost follow me around the ship, wanting to talk about aliens. Now, one of the talks that I created, I called Robots in Space, which is about various probes, in particular, the first ones like the Pioneer that went through the asteroid belt. So that was the first mission to actually successfully get through the asteroid belt, because until then they didn't know whether they could actually get through there. So Pioneer 10 and 11 were the very first. And after I finished this talk, a guy came down to the stage and introduced himself, and he said when he was a student, that was one of his jobs. He was part of the team that did the calculations for the Pioneer missions, going around each of the planets to work out how to get through the solar system and the asteroid belt. And he couldn't believe that something that he did when he was in his late teens, and he was in his 70s or something at that time, someone was still talking about something he did when he was a student. And then a guy came up to the two of us. I'm up on the stage, this guy was down here, and another guy came in. And out of the blue he says, the government's got to come clean. And of course, we know what he means, but we just sort of played dumb as soon as he made that thing, and we thought, uh-oh, incoming, here comes someone that wants to talk about aliens. And we said, so what do you mean? What have they got to come clean on? And he said, well, the pyramids. The pyramids, they say the pyramids were built by the ancients. And you know what we're going to say. And you know what he would say. So we asked him, so if the ancients didn't build the pyramids, who built the pyramids? Of course, he says, it was the aliens. The aliens built it. Well, because I've got my stuff set up, and I have to pack up and go. And this guy wants to talk about aliens, and this guy obviously doesn't. So I thought, this is a perfect time for me to pack up. So I took my laptop and all of my bits and pieces, and I headed off backstage to the side. And I left these two guys to discuss the ins and outs of aliens together, with the weird sort of look on his face with this question as to the aliens were the ones that built the pyramids. So I packed up went off to the side of the stage. When I came out, it was empty. They were gone. Both of them were gone. There was no one left in the theatre. I went off to the side. This talk, the podium was on the other side there, so I was off onto your right-hand side. So I walked out of the theatre, and just as I got to the door at the entrance, the guy that worked with NASA was standing there, and he said, "You left me." And I said, "I know." As soon as this guy started talking about aliens, I thought, this is my chance to get out of here. So exit, stage left, off I went, left him to his own devices. And he was able to finally, I guess, get rid of him, and the guy walked off. So since then, I've actually met a number of people that have been involved in various parts of the space race. A few years ago, I met a guy who worked on the Saturn V rockets. He was involved in the actual testing of the actual rocket itself. I forget what they call the Saturn V rocket, an F1 or something like that. So he was involved in the testing of those rockets with the firing and all that sort of stuff. About a year or so ago, I met a woman who was working on the escape rocket system for the Orion space missions, Artemis. And early this year, I actually met a guy who worked in the machine shop that manufactured the filter wheel for the James Webb. So a number of people that, because they come to my talk, they're people that on a normal cruise you wouldn't know who they were, but they sort of come to me to talk because they know we have something in common, and a common interest. So a number of people that have worked on various things. I haven't met any people that are actual astronauts yet. I have met Hadfield, but not on a ship. That was at a different presentation. So over the years, I've met a number of people from NASA, ESA, and some of the other space agencies and some of the companies that work for those space agencies, making some of the equipment for them. Roswell. Roswell can be a favourite topic of some of these people that want to talk aliens. There was one guy, every single talk I did, he sat at the front. My wife was with me and we said, "Mr. Roswell's here." And he'd be sitting there. So every time we saw him, there goes Mr. Roswell. So he would sit right at the front of all of my talks, keen, like if he could, he would actually interrupt my talk in order just to talk about aliens. So he's just sitting here at the front in this particular picture. Every time, if I was talking to people at the end of my talk, they would come up and want to talk about whatever the subject was, and he'd be waiting, hanging around, trying to butt in without sort of, being allowed in or anything like that. He just wanted to butt in out of the blue to talk more about his Roswell. I also try and organise at least one time during the cruise where I show people the meteorites that I bring with me, and there he is again, Mr. Roswell standing up there, and the little laser pointer doesn't, oh, there it is. Yes, there he is. He wore the same t-shirt every time. I don't know whether it had Roswell on the front, I wasn't really interested. But yes, he would hang around. These people are trying to ask me questions about the meteorites that I bring along, and he's trying to ask me questions about Roswell, about the things that were found, etc. So I've only ever seen him once, that's enough. So another question, of course, is, have I ever had any problems with border security? Right, you're bringing a suitcase that has a big lump of iron that is totally, like no X-ray can see through it. What is it? Have I had any problems with security with my luggage when I go through? They say, don't joke with them, don't even talk to them, right? You've got to be really careful. They don't have a sense of humour or anything. It's almost like, don't talk to them, they're not actually humans, right? So be very, very careful, particularly if they ask you questions. Just like, please tick the little box if you've got food, because otherwise you'll end up on TV, right? I don't really want to end up on Channel 7. I don't bring any food in, right? So have I had any problems? a couple of years ago, I was boarding in Melbourne, which meant I had no flights. Normally, I would put my meteorites into my checked-in luggage, and then when I get to, say, Sydney or Brisbane, hopefully they haven't lost my luggage, because all my meteorites are in there, because I don't want to put them in, or I can't, I'm not allowed to. They would take them off me. So I put them into the checked-in. Because I was leaving from Melbourne, I put them into my carry-on so it won't get lost. All my clothes, etc., are in my normal checked-in suitcase, but because this one was from Melbourne, there's no flights. So I put all my meteorites in my little carry-on suitcase so I could just walk on and go through the security. They can't get lost. Sometimes I've had suitcases, I don't get my suitcase delivered until the ship has left port 2 hours, and then my suitcase finally turns up, so I know it's not left back at wherever the port was. So I didn't want to lose my meteorites when I don't have to. Put them in the carry-on, they can't get lost now. What could go wrong? So you go through the X-ray, and I could see the picture of the X-ray. There was a woman operating the machine, and I could see this big black blob and all the other bits and pieces that are there. And she's looking at it and pointing. She beckons to someone else to come over. Another woman comes over. They're trying to work out what it is. So then they beckon to one of the guys and said, "Oh, can you have a look at this guy's suitcase?" So go over to the side, and here's 2 male border security officers, right, just like on Channel 7, are there, you know, just wondering what's in your suitcase. They're probably thinking, oh, they got some drugs or something like that. So I opened up the suitcase and took it out, and I explained what it was. I took it out, which was my big meteorite, because it's Melbourne, so I take my big 11 kilo, which I'll show you later. Normally I only take my little one, which is only 3 kilos, because it's a lot lighter in the suitcase. But I took it out and then showed it to them and what it was. Being careful not to sort of like, don't try and crack jokes with them or anything like that. So they get it out and they said, "Can we hold it?" So there's 2 border security guards there going, "Oh, can we hold this?" So they're picking up my meteorite, and one would say to the other, after they close the aisle off, so all the other passengers have to go through here, this one's closed because there's 2 border security guys are standing here lifting up my meteorite, saying to one another, "Okay, you take a selfie of this," and then pass it over. And the other border security guy's taking a photo. You're not supposed to take photos there unless you're border security, and they're taking all these pictures of one another, proud as punch, holding a meteorite. And then, of course, they gave it back to me and I got on the ship. If I have to go further, like in this particular case, I had to go to Hawaii, coming back over the Pacific. So I flew in a couple of days beforehand, because you don't want to land in Honolulu when the ship leaves, although they have done that to me. But in this particular case, I flew over a couple of days. This was just at the opening after COVID. So I had to get COVID tests. You had to wear masks everywhere, all this sort of stuff. So if it was a long flight, then I fly in a couple of days early, so I put the meteorites in my checked-in luggage, not in my carry-on, of course. So they go into my checked-in luggage. Never had a problem at the airport with checked-in luggage. It just goes through. It's like they look at the suitcase, you go, "Can't see what that is. Oh, it must be okay. We can't see through it." So it just goes through. Never had a problem. So I fly in the day or so early, and then in this particular case, I thought, I'll take my meteorites out of my checked-in, because I'm here, I don't have to fly now, I've landed. So I'll take the meteorites out and I'll put them in my little carry-on. So I'll put them on the carry-on, all the rest of the stuff goes through the normal checked-in path. Take my carry-on into the security just to get onto the ship. They won't get lost because they're not in checked-in. Go through the ship's security to board the ship. That's what I thought. I get to the X-ray. What's this? The guy says, "We've got something in your suitcase. We can't see what it is." Takes me over to the naughty corner, opens up the suitcase. And he said, I take the meteorite out. And he says, "What's this?" And I said, "It's a meteorite." "What's a meteorite?" So I explained to him it's come from space and all this sort of stuff. And hoping I'd get it back. He said, "It's too dangerous. I can't have it." He said, "We'll take this off you and you can get it back at the end of the cruise." But I said, "But I use this for my talks. You can't take it off me. How am I going to give my talks?" Because I have a number of talks where I use these meteorites to help illustrate those particular talks. You can't just take it off me. So they said it will have to go to security on the ship. So security would keep it and I would have to tell them when I need it. And I thought, would they take a trumpet off a band member because you're going to get the trumpet and hit someone over the head, like I'm going to hit someone with my meteorite? No thanks, too valuable. Would they take a trumpet off a musician? Would they take a chainsaw off a juggler or a sword off a magician? Maybe, I suppose. You can't really have a chainsaw on a cruise ship or a sword. So what I had to do at each presentation for this particular cruise, I would have to notify the cruise director, my boss, that I needed my meteorite. So someone from the staff would have to go down to security, sign it out, carry it the length of the ship, which is about 400 metres, up 4 flights of stairs. The first talk I did, this poor girl came in, she was probably about 18 or something, carrying my meteorite, and just 400 metres, nearly half a kilometre, carrying 3.5 kilos of iron in her bare hands. And she said to me, "Oh, the cruise director said I had to pick up something." She said, "I thought it was a piece of paper." So she goes down to security to get what she thought, and she ends up with 3.5 kilos of iron. She's got to carry nearly half a kilometre on the ship to give to me. And then at the end of the talk, I would have to give my meteorite back to one of the ship's crew, one of the entertainment people that would be there, and then they would have to take it all the way back to security and sign it in. And the next time I need it, I would have to tell the cruise director the day before that I would need my meteorite for a talk at 10 o'clock or whatever. He would organise for someone to get it and bring it up and give it to me, and then I'd have to hand it back again. And this was 3 or 4 times throughout the cruise so that I could get access to it. And I asked him about this after a few times of going back and forth on the ship. And he said he asked the security guy why I can't have it. And the guy said, "It's because I had the meteorite in my carry-on luggage, I can't have it. If I had it in my suitcase, in my checked-in luggage, it would have been okay." But I said, "But when I'm in the room and I have my carry-on suitcase and my checked-in luggage with me, isn't it the same? Like, what's the difference? Does it matter that this came on the ship through this suitcase, but if you had it in this suitcase, it's perfectly okay, not dangerous at all?" So I mentioned it to him that, "Isn't it the same?" And he just rolled his eyes and like, don't argue with ship security. So when I disembarked in Brisbane, I had to pick up the meteorite from the naughty corner, which is where people try and bring on things like bottles of spirits, ironing, all these different things that they try and bring on that they're not allowed to bring on. And my meteorite was there. The worry was you're actually completely off the ship, completely. You're totally disembarked. I even asked the entertainment director to ask security, could I have it on the night or the last night so I could pack it? And they said, "No, it's too dangerous. You can't have it in your room. You have to pick it up when you get off the ship. We can't give it to you." So I picked it up at the naughty corner when I got off the ship. I still don't understand why, and I've never had that problem before where I've come onto the ship and I've had it in my carry-on. I've done that several times. It was only this one particular cruise where it's been a problem. Batteries. Of course, the batteries should always go in your carry-on, not even an electric toothbrush. You shouldn't even have electric toothbrushes or anything like that in your checked-in, because if particularly it's a lithium one and it catches fire, you don't want a fire in the hold in an aeroplane, so you bring it with you. Not a problem. So any batteries that I've got, they go in my carry-on. So I have two spare AAA batteries that I carry with me just in case this goes flat. They just sit in the laptop bag, just like this. They've been there for a long time. I've gone through, in this particular case, I went through airport security in Melbourne, flew to Brisbane, went through airport security in Brisbane, got on the plane with these batteries in the laptop bag, in carry-on, not a problem. They've been in my bag for years. I haven't had to replace this yet. So they've probably been in there for 5 or 6 years. They've done probably at least a dozen flights, if not more. Never a problem. I get to Auckland and I'm in transit because Royal Caribbean had booked me from Melbourne to Brisbane to Auckland to Honolulu. And I said to my agent, it's a bit indirect, and she said some people went from Sydney to Brisbane to Auckland to Los Angeles to Honolulu. So don't argue. Yours was actually quite direct. So at Auckland, I'm in transit because they booked me on a different flight, a different airline, across to Honolulu. I go through the in-transit, through the X-ray, and the security person says, you've got some batteries in your bag. I said, yeah, I've got a couple of AAA batteries, spare. She says, you can't have them. They're too dangerous because these two batteries, you know, they might touch one another like this somehow or that, and you could get a spark and that could create a fire, and you don't want that. Anyone that knows about electricity is that's not dangerous until you put a piece of wire on the other end. If it was a 9-volt battery, I could understand if something metal touched. Short circuit, yes, I wouldn't do that, and I don't need one. But yes, she said you can't have these batteries. Don't argue. So I thought, well, you can have my AAA batteries. They're probably flat now anyway. So they took my potentially dangerous fire-causing batteries off me, and away I went. Right, you don't want to cause too much trouble with border security. Not all of them want to take selfies with a AAA battery. The Bentley Festival. So we were at the Bentley Festival in February of this year. Here's some of the happy little members here, smiling. Now I had my, as I always do, I had my big meteorite, this one, he's 11 kilos, and I take this. This is not the one that I put when I fly, because 11 kilos in your luggage, you haven't got a lot left for clothes. So I took this when it was Melbourne because I didn't have to fly. So I had this 11 kilo iron meteorite at the Bentley Festival. And there was a 12 or 13-year-old girl who was there, and she's testing how magnetic it is. No, it really sticks. And her mum comes up and she's interested in the dimples. So she's looking very carefully while her daughter is bashing away. And then she pulls it up, whacks her mum in the eye, right into the glasses, knocked her glasses off. Her friend that was with her absolutely cracked herself with laughter. I was pissing myself with laughter. It was so funny to see the mum with the glasses fly off from this magnet. Later in the day, I was explaining to another girl where this particular meteorite landed, which is in an area of northern Argentina up here. I said, it was about 6,000 years ago. And she said, were you there? And I thought, how old do you think I am, right? No, I wasn't there. Another thing that I bring to the Bentley Festival is my lump of tungsten. Not for anything to do with space, but because it's heavy. It's the same density as gold. So when you pick it up, it's a lot heavier than you think. I won't put it on the glass. So I've seen guys come to pick that up and they struggle because it's actually quite small. So you expect to just sort of grab it like this, but it doesn't move like that, does it? It's much, much heavier than you think. It also has one of the highest melting points of all the metals. You can actually, you can put gold in there, a gold ring, and melt the gold ring inside tungsten, and the tungsten won't melt. Very, very high melting point. It's so heavy that a number of people have accused me of having a magnet underneath here to make it seem like it's heavier than it is. But it's not. It's just dense, like some of the people that I've met on some of the cruise ships as well. But yes, it's much, much heavier. If you try and lift it, you have to really get a good grip because it's much heavier than you expect. You expect something about the density, the weight of iron, and it's a lot more than that. So that's just some of my stories that I could recall over the years where funny little things have happened. So I hope you enjoyed my little talk. So thank you all.
Anyone have any questions for Trevor?
Then you can come up and have a look at all that stuff later.
What's your chunk of tungsten worth?
A lot more now than what it was when I bought it. I think I paid about $300 US for this.
Yeah.
About 5 years ago. This is about $700 or $800 US now. Yeah. I wish I got the next size up because it's much, much heavier, and I could have got the next size up for less than what this is now, but I didn't know that.
But then again, you wouldn't get that through an airport.
Sorry?
You wouldn't get that through an airport.
No, well, they probably wonder what that is too, yes.
Yeah.
But I put that in the check. Yes.
I still been trying to find out to get to the bottom.
No, sorry.
How these dinosaurs went out of existence.
Yeah.
Did they stop breeding, or was it climate change, or
There
did
was
they
the
spend
meteorite
so much
impact was the main thing. They believed that they were on the way out anyway because their genetic diversification was getting less and less. So they probably would have been bred out of existence in the next few tens of millions of years or something like that. But because they never had a space race or anything, they didn't invent rockets, so they couldn't see the meteorite coming. They didn't invent telescopes.
Yeah, I see you told me years ago that these animals spent most of the time, sometime in water, and the climate changed and they couldn't get back to the water and they perished on land. I don't know about that.
Yeah, well, there were a lot of them lived in the water, a lot lived on land, but it wasn't just the dinosaurs, it was lots and lots of things as well. Right, I'll just shut this down. Right, move this out of the way. Right.
Okay, thanks for that, Trevor.
Okay.
One of the biggest mysteries of our existence is also one of the biggest mysteries of physics: time. We experience time as passing with a special moment that we call now. Now you're watching this video. Half an hour ago you were doing something else. Whatever you did, there's no way to change it. And what you will do in half an hour is up to you. At least that's how we perceive time. But what physics tells us about time is very different from our perception. The person who figured this out was none other than Albert Einstein. I know, that guy again. Turns out he kind of knew it all. What did Einstein teach us about the past, the present, and the future? That's what we'll talk about today. The topic we're talking about today is covered in more detail in my new book, Existential Physics, which will be published in August. You find more info about the book at existentialphysics.com. We think about time as something that works the same for everyone and every object. If 1 second passes for me, 1 second passes for you, and 1 second passes for the clouds above. This makes time a universal parameter. This parameter labels how much time passes and also what we all mean by now. Hermann Minkowski was the first to notice that this may not be quite right. He noticed that Maxwell's equations of electrodynamics make much more sense if one treats time as a dimension, not as a parameter. Just like a ball doesn't change if you rotate one direction of space into another, Maxwell's equations don't change if you rotate one direction of space into time. So, Minkowski said, we just combine space with time to a four-dimensional space-time, and then we can rotate space into time, just like we can rotate two directions of space into each other. And that naturally explains why Maxwell's equations have the symmetry they do have. It doesn't have anything to do with electric and magnetic fields. It comes from the properties of space and time themselves. I can't draw a flower, let alone 4 dimensions, but I can just about manage 2 straight lines, one for time and the other for at least 1 dimension of space. This is called a space-time diagram. If you just stand still, then your motion in such a diagram is a straight vertical line. If you move at a constant velocity, your motion is a straight line tilted at some angle. So if you change velocity, you rotate in space-time. The maximal velocity at which you can move is the speed of light, which by convention is usually drawn at a 45-degree angle. In space, we can go forward, backward, left, right, or up and down. In time, we can only go forward. We can't make a U-turn, and there aren't any driveways for awkward 3-point turns either. So time is still different from space in some respects. But now that time is also a dimension, it's clear that it's just a label for coordinates. There's nothing universal about it. There are many ways to put labels on a 2-dimensional space, because you can choose your axes as you want. The same is the case now in space-time. Once you have made time into a dimension, the labels on it don't mean much. So what then is the time that we talk about? What does it even mean that time is a dimension? Do other dimensions exist? Supernatural ones? That could explain the strange sounds you've been hearing at night? No, that's a separate problem I'm afraid I can't help you with. It was Albert Einstein who understood what this means. If we also want to understand it, we need 4 assumptions. The speed of light in vacuum is finite, it's always the same, nothing can go faster than the speed of light, and all observers' viewpoints are equally valid. This formed the basis of Einstein's theory of special relativity. Oh, and also the observers don't have to exist. I mean, this is theoretical physics, so we're talking about theoretical observers, basically. So if there could be an observer with a certain viewpoint, then that viewpoint is equally valid as yours. Who or what is an observer? Is an ant an observer? A tree? How about a dolphin? What do you need to observe to deserve being called an observer, and what do you have to observe with? Believe it or not, there's actually quite some discussion about this in the scientific literature. We'll sidestep this interesting discussion and use the word observer the same way that Einstein did, which is a coordinate system. You see, it's a coordinate system that a theoretical observer might use, dolphin or otherwise. Yeah, maybe not exactly what the FBI thinks an observer is, but then if it was good enough for Einstein, it'll be good enough for us. So Einstein's assumption basically means any coordinate system should be as good as any other for describing physical reality. These 4 assumptions sound rather innocent at first, but they have profound consequences. Let's start with the first and third. The speed of light is finite, and nothing goes faster than light. You're probably watching this video on a screen, a phone or laptop. Is the screen there now? Unless you're from the future watching this video as a hologram in your space house, I'm going to assume the answer is yes. But a physicist might point out that actually you don't know, because the light that's emitted from the screen now hasn't reached you yet. Also, if you are from the future watching this as a hologram, make sure to look at me from the right. It's my good side. Maybe you hold the phone in your hand, but nerve signals are ridiculously slow compared to light. If you couldn't see your hand and someone snatched your phone, it'd take several microseconds for the information that the phone is gone to even arrive in your brain. So how do you know your phone is there now? One way to answer this question is to say, well, you don't know. And really you don't know that anything exists now other than your own thoughts. I think, therefore I am, as Descartes summed it up. This isn't wrong, I'll come back to this later, but it's not how normal people use the word now. We talk about things that happen now all the time, and we never worry about how long it takes for light to travel. Why can't we just agree on some now and get on with it? I mean, think back of that space-time diagram. Clearly, this flat line is now, so let's just agree on this and move on. Okay, but if this is to be physics rather than just a diagram, you have to come up with an operational procedure to determine what we mean by now. You have to find a way to measure it. Einstein did just that in what he called Gedankenexperiment, a thought experiment. He said, suppose you place a mirror to your right and one to your left. You and the mirrors are at a fixed distance to each other, so in the space-time diagram it looks like this. You send one photon left and one right and make sure that both photons leave you at the same time. Then you wait to see whether the photons come back at the same time. If they don't, you adjust your position until they do. Now remember Einstein's second assumption: the speed of light is always the same. This means if you can send photons to both mirrors and they come back at the same time, then you must be exactly in the middle between the mirrors. The final step is then to say that at exactly half the time it takes for the photons to return, you know they must be bouncing off the mirror. You could say now at the right moment, even though the light from there hasn't reached you yet. It looks like you found a way to construct now. But here's the problem. Suppose you have a friend who flies by at some constant velocity, maybe in a spaceship. Her name is Alice, she's much cooler than you, and you have no idea why she's agreed to be friends with you. But here she is, speeding by in her spaceship left to right. As we saw earlier, in your space-time diagram, Alice moves on a tilted straight line. She does the exact same thing as you, places mirrors to both sides, sends photons and waits for them to come back, and then says, when half the time has passed, that's the moment the photons hit the mirrors. Except that this clearly isn't right from your point of view, because the mirrors to her right are in the direction of her flight, so the light takes longer to get there than it does to the mirrors on the left, which move towards the light. You would say that the photon which goes left clearly hits the mirror first, because the mirror's coming at it. From your perspective, she just doesn't notice, because when the photons go back to Alice, the exact opposite happens. The photon coming from the left takes longer to get back, so the net effect cancels out. What Alice says happens now is clearly not what you think happens now. For Alice, on the other hand, you are the one moving relative to her, and she thinks that her notion of now is right and yours is wrong. So who's right? Probably Alice, you might say, because she's much cooler than you. She owns a spaceship after all. Maybe, but let's ask Einstein. Here is where Einstein's fourth assumption comes in. The viewpoints of all observers are equally valid. So you're both right. Or, to put it differently, the notion of now depends on the observer. It is observer-dependent, as physicists say. Your now is not the same as my now. If you like technical terms, this is also called the relativity of simultaneity. These mismatches in what different observers think happens now are extremely tiny in everyday life. They only become noticeable when relative velocities are close to the speed of light, so we don't normally notice them. If you and I talk about who knocked at the door right now, we won't misunderstand each other. If we'd zipped around with nearly the speed of light, however, referring to now would get very confusing. This is pretty mind-bending already, but wait, it gets wilder. Let us have a look at the space-time diagrams again. Now let us take any two events that are not causally connected. This just means that if you wanted to send a signal from one to the other, the signal would have to go faster than light. So signaling from one to the other isn't possible. Diagrammatically, this means if you connect the two events, the line has an angle less than 45 degrees to the horizontal. The previous construction with the mirrors shows that for any two such events, there is always some observer for whom those two events happen at the same time. You just have to imagine the mirrors fly through the events and the observer flies through directly in the middle. And then you adjust the velocity until the photons hit both events at the same time. Okay, so any two causally disconnected events happen simultaneously for some observer. Now take any two events that are causally connected, like eating too much cheese for dinner and then feeling terrible the morning after. Find some event that isn't causally connected to either. Let's say this event is a supernova going off in a distant galaxy. There are then always observers for whom the supernova and your cheese dinner are simultaneous, and there are observers for whom the supernova and your morning after are simultaneous. Let's then put all those together. If you're comfortable with saying that something, anything, exists now which isn't here, then, according to Einstein's fourth assumption, this must be the case for all observers. But if all the events that you think happen now exist, and all other observers say that the events that happen at the same time as those events exist, then all events exist now. Another way to put this is that all times exist in the same way. This is called the block universe. It's just there. It doesn't come into being, it doesn't change, it just sits there. If you find that somewhat hard to accept, there is another possibility to consistently combine a notion of existence with Einstein's special relativity. All that I just said came from assuming that you're willing to say something exists now, even though you can't see or experience it in any way. If you're willing to say that only things exist which are now and here, then you don't get a block universe. But maybe that's even more difficult to accept. Another option is to simply invent a notion of existence and define it to be a particular slice in space-time for each moment in time. This is called a slicing, but unfortunately it has nothing to do with pizza. If it had any observable consequences, that would contradict the fourth assumption that Einstein made. So it's in conflict with special relativity, and since this theory is experimentally extremely well confirmed, this would almost certainly mean the idea is in conflict with observation. But if you just want to define a now that doesn't have observable consequences, you can do that, though I'm not sure why you would want to. Quantum mechanics doesn't change anything about the block universe because it's still compatible with special relativity. The measurement update of the wave function, which I talked about in this earlier video, happens faster than the speed of light. If it could be observed, you could use it to define a notion of simultaneity. But it can't be observed, so there's no contradiction. Some people have argued that since quantum mechanics is indeterministic, the future can't already exist in the block universe, and that therefore there must also be a special moment of now that divides the past from the future. And maybe that is so. But even if that was the case, the previous argument still applies to the past. So yeah, it's true. For all we currently know, the past exists the same way as the present.
Yes, the past still exists.
Utterly busy now.
You will be tested on it. Okay, and to close a couple of minutes on the evolution of the moon. This is courtesy of the Goddard Space Flight Centre, and it's set to a bit of audio called Titan by Cold Cinema. It's based on data from the Lunar Reconnaissance Orbiter that mapped out the moon's surface in great detail. and you'll notice how the Mara on the moon, you know, the dark areas that were thought to be seas by ancient astronomers, ancient observers, you'll see that they're formed from volcanism, and the craters that came after them from the impact of subsequent bombardments. Now, hopefully this is not too loud. And with the pounding of the moon, we'll close the meeting, and we hopefully will see you next meeting in August. Thank you for coming tonight.